All right, you might be wondering what in the world is this image all about, and hopefully by the end of this quick video you'll understand what the heck this is trying to say. Okay, so we are going to be looking at function operations and also compositions. Okay, function operations, I want you to think order of operations like PEMDAS, and then compositions, you might have never heard of this before, so I'm going to explain it real quick right now and then jump into function operations. Okay, so whenever we're dealing with a function, I want you to think it's just like an equation. So there's a y value, and then typically there's an x and maybe some extra junk in the trunk back here. Okay, now instead of the y, sometimes we write this with a notation like that where it says f of x equals 2x plus 1. Okay, so from here, we then evaluate functions given a particular value. So let's say that I wanted you to do f of 3, okay? And if I wanted you to do f of 3, what that means is everywhere you see an x, you're going to be putting in that value of 3, okay? Now, let's expand that a little bit further, and instead of doing f of 3, I wanted you to do f of 3x. What would you have to do? Well, certainly, you would, everywhere there's a variable of x, you're going to be putting in now 3x. Okay, now let's take that one step further. What if I wanted you to do f of 3, oops, let me get that green going, 3x minus 1. Okay, so what would you do if I told you to evaluate f of x with 3x minus 1? And you guessed it, everywhere we see the x up here, we're going to be putting in what it's asking, that evaluation value, so 3x minus 1. Okay, now let's say off to the side here, this is f of x, but this 3x minus 1 represented a different function called g of x. So g of x is equal to 3x minus 1. So essentially, what we just did is we took the g function, which I'll represent like this, g of x, and we put it inside the f function. Okay, so this is f of g. So another way of writing this, and I'll explain this in a second, is f of g of x. Okay, this is a little circle. I know it's kind of hard to see. Okay, so this is called a function composition. Now, to branch off from this, if I told you to take the f function, f of x, and I wanted you to then add it to the g function, you would understand, hopefully, that what I want you to do is take 2x plus 1, which that's what the f function is equal to, and I want you to add it to the g function, which we see is the 3x minus 1. Okay, then we would combine like terms, so that'd be 5x, and then the 1's just cancel. And so then we know f plus g is equal to 5x, like so. All right, let's continue on. So what are we going to see here? We see a truck inside a truck on top of another truck. And so when you understand this, this is saying there's a function inside another function inside another function. So the truck is inside one truck, which is on top of the other truck. Okay? Ha ha ha. It's a knee slapper. Okay, so the operations that we're going to see are not just limited to addition. Okay, so you could be taking f of x and adding it to g of x, and this is another notation on how they would write this. So if you see this, don't freak out. It means the same thing. That's what the equal sign represents. We could see multiplication, where we're multiplying two different functions. Notice that we're not going to be taking the f of x part, but we're just going to be taking what f of x is equal to. Okay, not the g of x part, this guy, but what g of x is equal to. That's what went in right here with our problems. Okay, so addition, multiplication, we can see subtraction in a similar way, and then also division. Okay, so we're taking two functions, and there's a missing line here, but there should be dividing by another one. All right, now in a nutshell, that's what compositions and function operations is all about. That should be enough to get you started on where you need to go.